So let's look at network layer attacks. So we have moved up the protocol stack. So let's start out with some background needed to understand these attacks. So what is the role of the network layer and what kind of service does network layer provide? That's right, the role of the network layer is end host delivery, and this is based on a best effort service model. You use datagrams and you employ a common IP standard such that every node can talk with every other node because everyone is following the same standard. So here is an example of an IP address. The things to note here that are of relevance are the source IP address, destination IP address. So these IP addresses that network layer employs, they have a structure which is a hierarchical structure. This ensures efficient routing. So if you look at any IP address, let's say IPv4 addresses are 30 bits long. This 32 bits are split into two parts. One is called the network part and another is the host part. So the network part identifies the network to which the host belongs to. So for example, when you deal with that extended LAN, so all the hosts within this extended LAN will belong to one given network, and thereby all these hosts will have this network portion the same, whereas the host portion will be different because the IP addresses each host gets has to be unique. Before any communication, the host needs an IP address as well as the default router's IP address. This is also very important because the host knows to contact this router to talk with the outside world. So without this router IP, it doesn't know how to talk with the outside world. As we have seen earlier, it will send, whenever it wants to contact any host in the outside world, the destination MAC is set to this router so that they come here and this guy will take care of it henceforth. Now the question is, how does a host get an IP address? Remember that these addresses have to be unique and there is a location dependency as well. In other words, hosts belonging to a given network should all have the same network portion. So you need to ensure this, both uniqueness and location dependency. So if you randomly take on some IP address, you cannot ensure these conditions. So often what is done is people use this DHCP protocol to ensure this. So that means we have to look at DHCP. So let's quickly cover this as well. So hosts dynamically get IP addresses from the server, which maintains a pool of available addresses. And these addresses it will hand out on demand, and these addresses are leased for a certain time. And once the lease is close to getting expired, the host has to renew this particular lease. So this also ensures efficient use of addresses, especially IPv4 addresses. We don't have too many. If you have only, let's say, 1000 IPv4 addresses within your organization and there are 2000 people, maybe the hope is that not all are active at any given time. Thereby, if they dynamically get these addresses, they can make better use of these resources. So these are all the advantages of DHCP. Because there is a server that is doling out IP addresses, this server will ensure that uniqueness as well as ensuring that a host for a given network has the same network portion. And it is automated. So we'll see the actual protocol details shortly. So this, you don't really have to do any manual configuration. It will also permit reuse of IP addresses, as I was mentioning here. And it supports portability. Portability means that if a host moves from one network to another network, things again fall in place. You don't really have to do too much configuration. The DHCP server will take care of it. So the question then is, fine, all this the server is taking care of, but how does the host know the address of this DHCP server in the first place? Because it's a chicken and egg problem. You're saying unless it has an IP address, a host cannot communicate. But to communicate to the DHCP server, you need an IP address. So how do you resolve this chicken and egg problem? Well, the solution is not so difficult. You make use of broadcast. That is, so you flood a message that says give me IP address, so that this will reach the DHCP server and the server will respond. So getting into the details, so this DHCP actually is an application layer process that makes use of the transport protocol UDP to handle this giving out of addresses. A newly booted attached host will broadcast. This is a network layer broadcast. What that means is in the destination IP address, you will use 255, 255, 255, 255. That means this will go as a link layer broadcast. But of course, the broadcast is restricted to a given physical network. That means that if you broadcast within the CSE department, that doesn't mean that this broadcast will reach the EE department or the outside IIT Delhi's network and so on. It is confined to within the physical network. This the routers will ensure. Within that physical network, all the hosts and routers will receive it, and one of them will be the DHCP server, which will reply to the host saying here is an IP address for you. So typically these are the messages that are exchanged. So host broadcasts this DHCP discover to discover what are all the DHCP servers that are available within this network. By the way, there can be more than one DHCP server, but each DHCP server will work with a different pool of IP addresses to avoid giving the same IP address to different hosts. So once the DHCP server sees this DHCP discover, it will do a DHCP offer. Again, as I said, more than one DHCP server may respond with a DHCP offer, and the host will select one among these as its IP address, and it will explicitly ask saying give me that particular IP address, and that particular server that gave that IP address will confirm this with a DHCP ACK. After this, the host will have the IP address. The DHCP server, apart from passing on the IP address to the host, will also specify the subnet mask so that the host knows what is the network portion within its IP address. This is important to know whether a neighbor is within its network or outside the network. So accordingly, it can send the link layer packet directly to the neighbor or to the router serving it. It will also get to know the default router. This is essential if you want to communicate with the outside world. It often is also told its domain name and the DNS server. So for example, iitb.ac.in will be the domain name for IITB, and this domain may be served by some DNS server, so that information also it can provide. These domain name and DNS server are optional, but the others, which is subnet mask, default router, are compulsory. So here is the DHCP packet format. What this means is that there is a network layer header, the IP header that we have seen, that is also there in the front. That will have the source as, because this guy who is starting out may not have, it may just have a source as 000 and destination as that 255, 255, 255, because this is a network layer broadcast. And within this network layer packet, this is the information that is put as part of the DHCP packet. So this has an operation, H-type, header length, hops. I mean, this you don't really need to know, except that we will touch upon this field later. So pay attention to this field. I will tell what this field does a little bit later. So here this YI address is often blank because you don't have an IP address. So in the request or discover messages, this will be blank. But when the server responds, this is the field it will fill with the IP address it is assigning. I think the same becomes clear here. So when the client is doing DHCP discover, this is the network layer IP header which you are putting this. And the DHCP is a UDP, so you need to specify the port information as well because it's a transport layer. You use 68 as the client port, destination port is 67, and this is again at the IP level. This is a broadcast address. This is a transport layer header. Whereas this is a IP layer header. The addresses are IP layer header. Because it doesn't have an IP address, this Y address field, which we saw just now, is set to 0. So the server is going to receive this discover packet because it is broadcast, and when it sends the offer, because the server has an IP address, it will definitely include its IP address. This is the port on which it is operating. Again, this is part of the transport layer header. This is part of the network layer header. Destination, it will still broadcast so that the message goes back to the specific client because the client still doesn't have an IP address. And this is the port, transport layer header port for the particular client, and it is saying you can take this address. And this address has a lifetime of 10 minutes. I didn't explain this XID. XID is nothing but a sequence number for that particular request, and you copy the same sequence number so that you know to match this offer with this discover. Then it will again ask for an explicit DHCP request. This also source destination. This also is broadcast because other DHCP servers need to know that this client is accepting this guy's offer and not their offer. It still doesn't take on the address because it is explicitly requesting for it, and in the options field it will specify that this is the address you had offered me, and in response to this the server will act saying okay, take this address. Again, this also has the same ID so that you can map all these belonging to the same session. So that is how the DHCP operation protocol works. So there is one other protocol that operates at the network layer, which is the ICMP protocol. Let's cover this as well briefly because some attacks make use of this protocol as well. So ICMP is essentially used for diagnostic purposes in the internet. So this is used by hosts as well as routers to communicate certain network level information. So for example, you sent a packet out with at the network layer, this is the source IP, this is the destination IP, and somehow the network was not able to deliver this packet, maybe because the host is not reachable, in which case the router that is serving this host D, if it is not able to deliver, will send back an ICMP error report to A telling unreachable host. Or maybe this packet reached all the way to D and there is a no process running on a given port, in which case D itself will send back an ICMP error message saying port unreachable. So this is what ICMP's role is. The ping, which I think many of you are aware of, is essentially an ICMP packet which is used to know whether some machine is up or down. So when you send this ping request, if the machine is up, it will send back a reply. Based on that, you can get to know some information like how much round trip time it took and so on. And more importantly, you know whether the machine is up or not. By the way, if you don't receive a reply, it doesn't mean that the machine is down. The machine can very well choose not to reply to a ping. That is up to the machine. So these ICMP messages are also carried in IP datagram. What this means is if this is part of the ICMP message, there will be an IP header associated with this, which you have to fill the source, destination and other fields in that IP header. Within the ICMP packet, which is the payload of the IP packet, all this type of information is carried. It has 8 bytes of header followed by some data. This is an ICMP header. This is not the IP header. There will be IP header on top of this. And this will give you some information on what type of ICMP packet it is. So type field will specify that. And sometimes when something fails, like for example, if you are not able to deliver a packet to a given process, some data portion of that packet is also specified as part of the reply so that the sender can make sense of what had happened. So that is what is listed here. So you send some packet, network layer packet. This will have some transport layer header as well. And the host D could not pass it to the right process. So when it is doing this ICMP reply, some portion of this packet, not the entire packet, but some portion of it, which is essentially the entire IP header and the first 8 bytes of the data, which is essentially the transport layer data, it will include here as part of the reply. So here are the types and code fields. Type 0 code 0 means it is echo reply. Type 3 code 0 means network unreachable. Type 3, type 7 means destination host unknown, and so on. So based on this, you interpret the ICMP packet accordingly. So here are more codes. I will let you go through them in leisure later. Let's move on. So that is the background. Now let's start looking at attacks and defenses. Again, much like before, we will start with eavesdropping, followed by disruption, followed by spoofing, and protocol specific attacks. As part of it, we will focus on the DHCP protocol.